In this demo, we'll show how to use Augment to migrate a Python module to Java in a large, complex codebase. So the codebase I have open here in my IDE is a legacy proprietary codebase consisting of a variety of backend languages, including Python, Java, Scala, C, and C++. I have a few tasks assigned to me in my latest sprint that involve migrating some of the Python modules over to Java. So I'm going to show you how to do that with the Augment agent and how to pass in the appropriate context. So the first thing I'm going to do is get familiar with the tickets that I have assigned to me. So I'll ask the Augment agent what tickets are assigned to me. And this is using the native integration that I've configured in the Augment settings with Linear specifically. You can also use this with Jira or GitHub or other project tracking platforms as well. So we can see that the tickets that I've pulled up in Linear include a variety of migration tasks. The first one that I want to migrate right now is this memory and caching system that lives in Python currently. We want to migrate over to Java. But before I do that, I want to make sure that I provide the agent with the appropriate context and project details so that it can access the relevant modules within the codebase and also understand the best practices of our organization and the proper methods to use when performing the migration. So I'm going to open up the Augment memories file found here. So this includes specific details of performance considerations in addition to general migration best practices that I've taken from our best practice documentation. So I'll close the memory file and then instruct the agent to kick off the work. So the agent works in three main parts. The first part is it calls the context engine and file access tools to better understand where in the code base it's making the edits. So there's a lot of different places that might involve memory and caching functionality, but we specifically want the Python modules so we can convert them to Java. So the first phase that the agent will try and do is it will understand where this lives in the code base. The second phase is it will create a detailed plan on how to execute the migration and implement the new code that we're creating in Java. And then finally, the third phase is it's going to execute the plan and implement all of the changes. So as an optional step, and I didn't include it in this part, but what you can optionally do as well is suggest to the agent either in the memories or in the prompt itself to pause after the plan has been generated so you can review it with the agent and fine-tune it as needed. In this case, it's self-contained enough where I am going to implement the plan that Augment proposes from the original implementation planning. We can see also that there were a couple of places in the codebase that Augment was unable to read during the first pass, but what the agent will do is it will recover and try a variety of different methods to access the appropriate functionality when it's performing the migration. So once our final changes have been completed, we can review them in the checkpoint window to make any modifications as needed and discard changes that maybe are unnecessary. But we can see here it added several files to help assist with the migration as well. And as an optional future step, we could ask the agent to help us deploy the new code into our environment. So hopefully this was helpful in showing how you can migrate Python to Java in a large legacy codebase and how you can use the agent to accelerate the development time. Thank you.